So again, we're on unit 5, systems of equations. And today we're going to be looking at elimination. Okay, so last time we had class, we focused on graphing and substitution. I think I spelled elimination wrong. Elimination. Right. So systems by elimination is exactly what it says. Okay, we're going to eliminate. All right, and when we're eliminating, we're looking to get rid of one of the variables. Okay, the x or the y. Um, and then once we get rid of that variable, then we're going to solve. Okay, so we're just going to go through examples and look to solve this. So here's our first example. Example 1. So we have x plus 3y equals -2, and x minus 3y equals 16. All right. So with elimination, we're looking to eliminate one of these two variables. Okay. And how we eliminate them? Well, we're looking at opposites. So remember opposites, positives and negatives are opposites of each other. All right. So like 3 and -3 are opposites. 7 and -7. Those are opposites. All right. So what we're going to do here is we're going to make sure that we have opposites either in my x or my y. All right. So step 1, we're going to look for opposites with x or y. If not, multiply to create opposites. So what I mean by that is, and we'll do that in our next example, but let's say if this was a +3 instead of a -3, well then we would have to multiply one of these two equations by something to change it in order to create that opposite. Okay, so we're going to look here. Do we have opposites? Yes, have opposites right here in 3y and -3y. Okay, so once we have our opposites, all right, now step 2, we're going to add both equations together to eliminate. I'm having a world of trouble spelling today. All right, so when I say add them together, we're going to stack them. All right, so like in elementary school when you learn how to add like 5 plus 3, that has you stack it. Okay, so we're going to stack these. So we're going to have, we'll just write it right here. X plus 3y equals -2 plus x minus 3y equals 16. Okay, so we're going to add these vertically. All right, so when I'm adding these vertically, x plus x, remember it's the invisible 1 there, is 2x. And 3y plus 3y, those are opposites, so they cancel, equals -2 plus 16 is going to give me 14. All right, so now once we add them together, now we're going to solve. Okay, so we can make that step 3. Once we add them together, now we're going to solve for variable. In this instance, our variable is x. Okay, so I'm going to solve for x here, and we just use our rules for equations. Opposite of multiplication is division. Divide by 2. What we do to one side, we have to do to the other. And x is going to equal 7. Okay, so I've solved for x there. So just like our last class, we are not done because we have to solve for y now. All right, so we have one more step here. Step 4, we're going to use solution from step 3 sub into one of the equations. So it doesn't matter which equation, all right? We can use either or. One of the equations to solve for last variable. To solve for other variable. Okay, so whatever we got in step 3, which is here, x equals 7, we're going to take this and we're going to sub it into either one of these two equations. It doesn't matter which equation, so don't get hung up on that. Don't think, oh my gosh, I have to use this one. Okay, it doesn't matter which equation you sub into. All right, we're going to sub it into one of these to solve to get y. All right, so I'll just use x plus 3y equals -2. Okay, I'm going to take my answer here and I'm going to sub it in, not y, to x. Good grief. I'm having a day, let me tell you. Plus 3y. We're going to sub it in for x. Okay, so I sub it in, 7, put in parentheses, show substitution, plus 3y equals -2. Subtract 7 from both sides. Bring down what's left. 3y equals -2 minus 7 is -9. And then my last step, divide by 3. Divide by 3. Y equals -3. So then my solution is going to be 7, comma, -3. That is my solution there. All right. So that would mean that if I was to graph these two, they would intersect at 7, -3. All right. Now, one thing to remember is if you're unsure about your answer, and that happens a lot in math, we do something we're really unsure about what we're doing, especially with something new, you can take your solution, we have x and y, we can plug it into one of these two equations, and we can solve it to make sure both sides equal each other. If both sides equal each other, you're correct. If they don't, you need to go back and double check your work. Okay? So I'll give everybody a second to get that down. All right. One thing to notice, and I'm sure you are thinking, well, when do I use graphing? When do I use elimination? When do I use substitution? Okay. We're going to work some examples in the future to help you realize that. All right. But for now, if you look at the example I gave you today, this example is in standard form. All right. If it's in standard form, most of the time you're probably going to use elimination. Well, if you're not comfortable with elimination, well, you can change those to slope-intercept form to graph them if you need to, if that's what you're comfortable with. Now, if both equations were slope-intercept form, obviously I would probably graph those, okay? But if it's slope-intercept form as well, you could also use substitution because you have y by itself, all right? So it's all about your personal preference and how you want to go about it and what you're comfortable with. So let's look at another example. Example 2. And we're still on elimination. Let's say I have -6x plus 5y equals 21. And my other equation, 2x minus 4y equals 14. So if we remember the last step from the last example, we said look for opposites with x or y. If not, multiply to create opposites. Look at x and y, okay? -6 and 2, these are not opposites. 5 and 4, these are not opposites. Now we have to create opposites, okay? So our first step here, and I'll write exactly what we're going to do, okay? My first step is I'm going to determine whether or not I want to make x opposites or y. I can do either or, all right? But what we need to determine is what's going to be the easiest way to do this. Now, 2 can be multiplied by 3 to make 6, which means if I multiply this bottom equation by 3, I don't have to do nothing to the top, all right? So that makes life a lot easier on me. I don't have to do anything to both of them, okay? But now if I look at the y's, 4 will not go into 5. 5 cannot be created to multiply to get 4. So I would have to find a common multiple, which is 20. So that means I would have to multiply the bottom by 5 and the top by 4. That's going to be a lot of extra work on myself. Okay. Now, you're not wrong if you do it that way, but we want to try to make this as easy as possible. So the first thing I'm going to do is I'm going to multiply the bottom equation by 3 to create opposites. Okay, so I'm going to multiply this whole entire bottom equation by 3, because that's going to give me an opposite. So when I multiply that by 3, it's almost like distributed property, but you're just multiplying every single term by 3. And we're going to change this equation. So now this equation is going to become, this will multiply here, multiply here, multiply here. This new equation will be 6x minus 12y equals 42. Okay, that's my new bottom equation. All right. So we've gotten that done. If we go back, step 2, we're going to add both equations together. All right. So my step 2 here, we're going to stack to add. All right. So let's just take this equation and let's put it below this. So negative 6x plus 5y equals 21. And we're going to add these together. Okay, we're going to add these vertically. So now when I add these, 6x minus 6x, those cancel, okay? Negative 12y plus 5y is going to give me negative 7y equals 42 plus 21 is 63. So we've just added these vertically. All right, now we're going to solve for the variable. So step 3, we're going to divide both sides by negative 7. All right, so we're solving for the variable here. So I'm going to divide by negative 7. What do to one side? I do to the other. And it gives me y equals negative 9. Okay, so we've solved for y here. Y is negative 9. All right, but we have one more step left here. If we remember our last step, we're going to use the solution from step 3, sub it into one of the equations to solve. Okay, so it doesn't matter which equation we sub it into. All right, so step 4, we're going to sub negative 9 into either equation and solve for x. Okay, so I pretty much have 3 equations to choose from here. Okay, I could choose this one, or this one, because remember, we created a new equation. All right, but I probably wouldn't use this one because this one's just a lot larger than that one there. All right, now it doesn't matter again which one you choose. It's all personal preference. I would probably choose the one with the smaller numbers. That might make it a little easier on you. Okay, so let's say we choose 2x minus 4y equals 14. And we're going to sub negative 9 in for y here. So 2x minus 4, use my parentheses show substitution, negative 9, sub that in there, equals 14. Now we're just going to solve like a 2-step or a multi-step equation. All right, so simplify. So 2x, negative 4 times negative 9 is positive 36 equals 14. Now I'm going to subtract 36 from both sides. Bring down what's left. 2x equals negative 22. Divide by 2. Divide by 2. X equals negative 11. So then my solution now is negative 11, comma, negative 9. And that would be our final answer there. Okay. And again, if you solve this and you think you're wrong, you can always take these two and sub them back in. So if I sub those back in, 2x minus 4y equals 14. All right, I'm just going to sub them in and see if they work. So 2, sub my negative 11 in, minus 4, sub my negative 9 in equals 14. Simplify, negative 22, positive 36 equals 14. Is that right? Yeah. So when I combine these, I get 14. Does 14 equal 14? Yes, that means my answer is correct. Okay, so there's always a way to check your work. All right, and again, this goes back to what we talked about the other day. If you understand equations, it will make math that much easier for you. Okay, equations are the foundation of basically all math. All right, it's where everything starts. Okay, so does anybody have any questions for me? All right, so if you don't have any questions,